Hi everyone, Mrs. Belo here. In this video, I'm going to be going over some important skills that you will need to know moving into chapter 13. The first skill will be moving the decimal or metric conversions. This is a skill that we've been talking about pretty much all year, and it's also something that's really important next year in physics. Molarity and molality, you will have to calculate molarity later in chapter 14 and 15 when we start talking about acids and bases and concentrations, so I still want to review that. And you will have to be able to calculate molality moving forward in chapter 13 because there is an equation that requires you to calculate molality, which is the little m. And then we will also be doing some double replacement or displacement reactions, which we actually covered last semester. I will be going over all these problems in this video, possibly 2 videos, so you can feel free to pause at any time so you can try some on your own and then continue watching so that you can check your work. So the first thing I'm going to go over is metric conversions. Now, there was some confusion with this in the last unit. You can only convert between the same base units. So, for example, you can only convert like gram to kilogram, milliliters into liters. We don't move the decimal to convert like grams into milliliters. Doesn't work like that. You can only move the decimal to convert between the same base unit. These are the metric base units: meters, grams, liters, and seconds. For our class, we primarily focus on grams and liters. However, next year in physics, you'll be using other units of measurement like meters and seconds. So these are the base units, and then in front of those, so you could have just these base units: a meter, a gram, a liter, or a second. And then you can also put you could put a prefix in front of that. So you can have a decigram, you can have a centigram, you can have a milligram, decagram, hectogram, and or kilogram. And the same thing goes for liters. You can have a deciliter, a centiliter, a milliliter, which is what you are more familiar with, a deciliter, a hectoliter, or a kiloliter. Now, as far as this class goes, and even next year in physics, the main units that you're going to be focusing on for now are milli and kilo and base unit, and then next year in physics, you'll most likely also be using centi. The reason that we can move the decimal to do these conversions is because all of these are in bases of 10. And if you are not comfortable with moving the decimal, you can always do a picket fence. If you choose to do a picket fence, I would remember these conversions. So 1 gram is equal to 1,000 milligrams. Or you can say 1 liter is equal to 1,000 milliliters. That's the same thing. So essentially, 1 base unit is equal to 1,000 milli base units. So that's an important one to know. And I would also know that 1 kilo base unit, so for example, 1 kilogram is equal to 1,000 base units. So for example, there's 1,000 grams in 1 kilogram, or 1,000 meters in 1 kilometer or kilometer. Those are the 2 main ones that I would know if you choose to do a picket fence for these metric conversions. Otherwise, you can just move the decimal because these are in bases of 10. So if we want to convert 500.67 grams into kilograms, we would start at grams, which is the base unit. That's what this is in right now. and then we would move the decimal to kilograms. So that would be 1, 2, 3 spaces to the left. 1, 2, 3 spaces to the left. This would be 0.50067 kilograms. You could also, using these guys here, you could also do, if you're choosing to do a picket fence, grams. Well, there's 1,000 grams in 1 kilogram. So you can also do, mathematically speaking, you can do 500.67 divided by 1,000, and you still get the same answer. I would definitely recommend putting this on your periodic table, or you can always, this is how I remembered it. I always remember King Henry died, and then you have your base units here, drinking chocolate milk. So this is how I've personally have remembered this. King Henry died, pause, and then drinking chocolate milk. So then your base units go here, and then each of those letters stands for those prefixes that it corresponds with. So this would be a good time to pause the video and to do the next 3 problems on your own, and then you can continue watching to get the correct answers. All right, so next I'm going to convert 1.23 liters into milliliters. So liters, that's our base unit that is here, and we have to convert it into milliliters. So I would move 1, 2, 3 spaces to the right. 1, 2, 3. So my decimal is here. So that would be 1,230 milliliters. Next, I'm going to convert 4.32 kilograms into grams. So kilo is here, and I need to convert that into grams. So I would move 1, 2, 3 spaces to the right. 1, 2, 3. So that'd be 4,320 grams. And then lastly, I have 1,512 milliliters, which is here, and I need to convert that into liters. So I would move 1, 2, 3 spaces to the left. 1, 2, 3, 1.512 liters. So again, you're basically starting at the unit you're given, and then you're moving the decimal to the unit you want your answer in. Again, I would recommend writing this on your periodic table somewhere. All right, next I'm going to go over molarity and molality. So molarity, remember, is using the triangle here and or the equation. Molarity is a way to measure concentration. This is how personally I would make solutions for a lab for you guys. This is actually how I would do it, is this type of calculation here. So molarity is equal to the moles of the solute. This is whatever substance that gets dissolved, and this is usually provided in the form of a chemical formula in a problem. And then liters of the solution, that is your volume. So this is usually, for now, the solute is represented as part of that solution, and for the most part it's going to be water. So we'll take a substance of some sort, usually an ionic compound, and dissolve it in water to create a solution. So the solute is whatever you're dissolving or what you have less of. The solvent is what you have more of, or 99% of the time it's water. So this question is asking, what is the molarity? So molarity is equal to, again, you can use the equation here, or you can use the triangle here. If you're solving for molarity, look at the relationship between the other two variables. It's moles over liters. So we're solving for molarity, which is moles divided by liters. And it looks like I have my volume of the solution in milliliters, because that's how much water there is. So that would be, let me highlight. Let's make it blue. Why not? Because that's water. Okay, that's going to be this value here. And then it says if we have 100 grams of CaNO3 too. So that's going to be our solute. So both of these we have to convert before we plug into the equation. So the first thing I'm going to do is I'm going to convert the 500 milliliters into liters. Well, we just did that. So if we have milli and we need to get it to liters, we would move 1, 2, 3 decimal places to the left. 1, 2, 3. So that is 0.5 liters. And then I need to convert 100 grams into moles. In order to do that, we have to calculate molar mass. So this would be another good time to pause the video to calculate the molar mass of CaNO3 too, because this does have the parentheses, so it's a good thing to, it's a good skill to review how to calculate those type of molar masses. All right, so I'm going to go ahead and do that. So I have calcium. So calcium is 40.078. And there's only one of those. Plus nitrogen is 14.007. Now remember, this 2 gets distributed to everything inside of the parentheses. So there right now there's 1 nitrogen. So we would do 2 times 1, which is 2. So we're going to multiply this by 2. Plus, we always use 16 for oxygen. 2 times 3 is 6. So we'd multiply this by 6. And then that's my molar mass, which I'm going to put here in the bottom. That is always equal to 1 mole. So I have 40.078 plus we have 2 times 14.007. And then plus 6 times 16. Just remember order of operations, 164.092 grams. So I'm going to go ahead and do 100 divided by that number to get my number of moles, 0.609414. I'm going to use all the decimals, 231. And then I'm going to divide that by 0.5 to get, I'm going to go 4 significant figures, 1.219. So equals 1.219, and then you just write a capital M for molality, or molarity, excuse me. In the next video, I will go over how to calculate molality, and then I will also go over the double replacement or displacement reactions.